Hi guys, it is me back with another video. In this video, I will be discussing blood flow mechanics. My name is Abhay. So let us begin. So guys, in order to understand this blood flow mechanics, we should first know what is flow equation. So flow equation is called as delta P is equal to Q into R. Okay, where delta P is called the change in blood pressure. Q is called as the cardiac output and R is called as the total peripheral resistance. Okay, and this equation is used to calculate cardiac output resistance or delta P. Okay, and is often applied to body and lungs. And for both systems, we use Q as a cardiac output. Okay, so what is the difference between the resistance and compliance? So resistance is basically how much the artery resists to blood flow. Okay, and compliance is basically distensibility of vessel, like how much it can spread. Okay, you can understand it like this. Okay, so so when it comes to stiff vessel, the stiff vessel has more resistance and less compliance. Okay, so that's why the blood pressure is very high in this kind of individuals. Okay, and stretchy vessels have low resistance and high compliance. Okay, so this stretchy vessels are, they are also called as the healthy vessels, and stiff vessels are called as the pathological vessels. Okay, and you should know that arterioles have the highest resistance. Arterioles, these are a kind of arteries. Okay, so we have got five type of vessels: aorta, large arteries, small arteries, arterioles, and capillaries. Out of this, you should only know that when the blood passes through the arterioles, the fall in the BP is very high. Okay, it is around 35 mm of Hg, and this is very important. Okay, so yeah, so this arterioles are, they are also called as a resistance vessels. Okay, and they are a major determinant of a total peripheral resistance. Okay, and as I told you that there is a high pressure drop in the arterioles, and vasoconstriction increases the TPR, that is a total peripheral resistance, and vasodilation causes a decrease in the TPR. Okay, now coming to the pulse pressure. So pulse pressure is basically the difference between the systolic BP and diastolic BP. Okay, and it is in very close relation to the compliance. Okay, now older and hypertensive people, they have more pulse pressure. Why? Because they have a stiff vessels, and stiff vessels are called as a pathological arteries. Okay, or vessels. Okay, so yeah, and pulse pressure and compliance are inversely proportional. Like so, the if the artery has less compliance, then the pulse pressure will be high. Okay, and if the artery has more compliance, then the pulse pressure will be low, which is ideal in case. Okay, let us discuss what is compliance. So compliance can be calculated by the equation called as the compliance is equal to change in volume by change in pressure. So as you can see in this equation, that the change in pressure is inversely proportional to the compliance. Okay, so so whenever a stiff vessel is there, there will be less compliance. Okay, why? Because it has more resistance. Okay, just uh, just try to remember it like this. Okay, and therefore there will be more change in pressure. Okay, so what will happen? There will be increased pulse pressure. Okay, and a stretchy vessel, they will have more compliance, so less change in pressure, and therefore less pulse pressure. Guys, actually I don't know how to pronounce this. Is it poisons? What is it? Poisons law? Poisons. Okay, whatever it might be, but it is important. So resistance, this R, this capital R, is equal to 8 into eta into L divided by the pi r raised to the raised to the power 4. Okay, so as you can see in in this diagram, the resistance is directly proportional to the eta, that is the viscosity of the blood. Okay, uh, so if the blood is viscous, that is it has more ingredients in it. By the term ingredients, I mean the just WBC, RBCs and platelets, all the stuff which make the blood. Okay, so whenever the viscosity of the blood is high, it will cause a increase in resistance, as it is directly proportional. And if the length of the artery is more, then it will also cause the increase in resistance, as you can guess. Okay, and resistance. Okay, so this is very important. So this resistance is raised to the power 4. Okay, so this will cause a very massive increase in the resistance. Why? Because it is raised to the power 4. Okay, as I have explained in my previous slide, viscosity is basically the thickness of blood. Okay, now viscosity, you can imagine it like water. Okay, water and honey. Which fluid will flow faster in a pipe? Tell me. It will be water. Why? Because it is less viscous. Okay, and low viscosity is associated with anemia, and high viscosity is associated with polycythemia, multiple myeloma, and spherocytosis. Okay. Guys, this is very important, so pay attention to this. What is mean arterial pressure? So it is basically diastolic blood pressure plus 1 by 3 into pulse pressure. Okay, pulse pressure is basically systolic minus diastolic. Okay, so total body pressure is arterial blood pressure is 120 by 80. Okay, so mean arterial pressure will be 80 plus 1 by 3 of 40, that is equal to 93 mm of Hg. And in lungs it will be pulmonary artery pressure is 40 by 20 mm of Hg, and mean arterial pressure will be 20 plus 1 by 3 of 20, which is pulse pressure, that will be equal to 27 mm of Hg. So guys, I've got a question. In this question we have got the cardiac output, which is 5 liters. BP is 155 by 80 mmHg. Right, it will pressure 5 mmHg, and they are asking to find us a total refill resistance. So pause and try to answer this question. So guys, what is given? Cardiac output, BP, and right atrial pressure. Okay, so we know the formula delta P is equal to cardiac output times TPR. Okay, so we can rearrange this formula and create a formula called as a TPR is equal to delta P by cardiac output. Now, what is the value of the delta P? It is mean arterial pressure minus right atrial pressure. Okay, so uh, now what is the formula of the mean arterial pressure? It is diastolic plus 1 by 3 of the pulse pressure. So diastolic is 80. Okay, wait. Yeah, so this is 80, and 1 by 3 pulse pressure is basically the systolic minus diastolic, that is 55, 155 minus 80, that is 75. Okay, so this comes out to be 105. Okay, now coming to the, so therefore TPR is equal to mean arterial pressure minus right atrial pressure divided by the cardiac output. So mean arterial pressure comes out to be 105. Okay, this right atrial pressure comes out to be 5. This is given in the question, and cardiac output is basically 5 liters. So our answer is 20. Okay, so this was a very simple question, and I know you might have answered this in the in the exam. So guys, thank you for watching, and bye. And remember to subscribe कर जल्दी, ठीक है ना?